Hello students. Today we go through miscellaneous exercise 4, the sums which are based on maxima and minima. The first question, choose the correct alternative. From here we have to do the sixth question. That is, if fx is equal to 3x cube minus 9x square minus 27x plus 15, then certain options are given here. That is, f has maximum value 66, f has minimum value 30, f has maxima at x is equal to minus 1, or f has a minima at x is equal to minus 1. Let us see how to do this sum. Now over here our fx is x cube, 3x cube minus 9x square minus 27x plus 15. So first step is as usual f dash of x, finding f dash of x, which turns out to be 9x square minus 18x minus 27. 15 becomes 0 as you know. The next step, finding f double dash of x, that is finding the derivative of f dash of x, which comes out as 18x minus 18. We can take 18 common here and then we get x minus 1, 18x minus 1. Now for finding maxima or minima, we put f dash x as 0. So f dash x is 0 when this particular equation is 0. That is 9x square minus 18x minus 27 is equal to 0. So in this case 9 can be taken common. We get a quadratic equation in the bracket like this. Then taking 9 on the RHS, 0 upon 9 becomes 0. So this equation we get like this. Now solving it by splitting the middle term, we are going to get x minus 3, x plus 2, x plus 1 is equal to 0. Solving both the brackets, we get x is equal to 3 or x is equal to minus 1. Now in the question, if you remember, they have asked the answer for x is equal to minus 1. So let us check this out. Maybe our sum will become shorter then. So at x is equal to minus 1, we calculate f double dash of x. That is, we calculate f double dash of minus 1. So that becomes 18 into minus 1, which becomes 18 into minus 2, which is minus 36. Now minus 36 is negative, so we write it as less than 0. And we know that if f double dash has a negative value, then the function has a maximum. So we write f has maximum, okay, at x is equal to minus 1. So this becomes our option. Correct option is C over here. F has maxima at x is equal to minus 1. So this becomes our correct answer here. Now next, in the miscellaneous exercise, we go through fill in the blanks question. So fill in the blanks question over here, the second one, not the second one, rather over here, this second one, third one and fourth one. These three questions deal with maxima and minima. As you can see over here in this question, fx is given. You have to find out f double dash of x. That is the second order derivative you have to find out over here. Same thing has been done for the third question. We'll see the fourth question what it is. So let us try out the second question. So this is the second question for fill in the blanks. That is second question, second one. Now here fx is given as x cube minus 3x square plus 3x minus 100. So first we find f dash of x, which comes out as 3x square minus 6x plus 3. And then we are supposed to find out f double dash of x, that is the second order derivative, the derivative of f dash x, which comes out to be 6x minus 6. So this becomes our answer. So this is all that has been asked. The third question is, you can do it in the same way like the second one. So this I leave it as an assignment for you. Now we come to the fourth question. In the fourth question, let me take a fresh page here. In the fourth question, what has been asked is that the question is like this. A rod of 108 meter length is bent to form a rectangle. If the area of the rectangle is maximum, then its dimensions are. Now last lecture I told you, such a sum has been done already in the last lecture. Dimensions means length and breadth. So this rod is bent to form a rectangle. So suppose this is a rod. It is of 108 meter length. Now this rod is converted into a rectangle like this. So that 108 meter becomes the perimeter of the rectangle. So over here, perimeter of the rectangle is given as 2 length plus breadth. Perimeter means the length of all the 4 sides, sum of the length of all the sides of a particular figure. So in this case, for a rectangle, it is 2 length plus breadth is the formula. Suppose, let the length be x and the breadth be y for the rectangle, for our rectangle. In this case, when the rod is bent to form a rectangle, the perimeter becomes 108 meter. So we write 2x plus y is equal to 108. Thus, x plus y becomes 108 divided by 2, which is 54. So we say that y is equal to 54 minus x. Now, what about the area? Area is supposed to be maximized over here. Area for a rectangle becomes x into y. Length into breadth, which is x into y. So we have x into 54 minus x. Okay, this becomes the function to be maximized. So we say that let fx is equal to x into 54 minus x. Simplifying that, 54x minus x square. Now what you can do is you can complete this sum as an assignment and find the answer over here. Okay, already a very similar sum has been done in the previous lecture in the exercise. So you can observe that and complete this sum as an assignment. Now we move on to the next question. State whether the following questions are true or false. Now in this question, only one sum is there which deals with maxima and minima. The question is, an absolute maximum must occur at a critical point or at an end point. What is the meaning of absolute maximum now? See, suppose I draw a graph over here. Suppose I draw the graph of a particular function. Say the graph comes out to be like this. Okay, from the definitions which we learned in our last lecture, we see that this function has local maxima and local minima. Now, let me draw this function in a better manner, like this. Where the function say turns out to be this way. As you can see, there is a peak over here at this point. There is one more peak over here at this point. The largest peak for a function is known as absolute maximum. So this particular part of the function, this particular peak is called absolute maximum for a function. So that is the meaning of absolute maximum. Now what is the meaning of critical point? Critical point. Now the critical point for a function is that value at which the derivative of the function is 0. The critical point is that point of the function. If the function is fx, the critical point is that point where f dash x is equal to 0. Now over here, at this absolute maximum, if you draw a tangent over here, like this tangent has been drawn. This tangent is a straight line, horizontal line, and therefore its slope is 0. If you remember, slope of the tangent of a curve is the derivative at that particular point. So this point gives us the value, the slope of this point, this line gives us f dash of x. So slope of this line, which is horizontal, that is parallel to the x-axis, is 0, and therefore we say that f dash x is 0. So this point is a critical point. So the first part of the function, the first part of state true or false, the question was this way, state true or false. The first part is true obviously. An absolute maximum must occur at the critical point. So at the absolute maximum, yes, of course we have a critical point like this. Isn't it? This is an absolute maximum, the maximum most part of the function. Over here there is a critical point where the derivative is coming as 0. So this part is true. What about the second part? The second part, the absolute maximum must occur at a critical point or at an end point. We can have absolute maximum at the end point of a function also. At the end of the graph also, the function can have a peak. And therefore, this statement is nothing but true. So we write true for this particular statement that is there. Then we move on to the next question. Now in the next question, I should remind you all that activity is not there for you all, at least in this syllabus. The board has deleted certain portions from your syllabus. Activities from all the lessons of Maths 1 have been deleted. So activities we don't have to do. But we can at least try out the fifth and the sixth sum. The fifth question of question number 4, solve the following. The fifth one, if x plus y is equal to 3, then show that the maximum value of x square y is 4. This is the question. If x plus y is equal to 3, then show that the maximum value of x square y is 4. Let us see it actually. Now before that, I remind you all that the sixth question you can do it as assignment. This I will not be solving it for you here because we have already done similar sums earlier in the last lecture. So this sum can be done as assignment by you. However, this sum, let us see what is the answer. Now for this particular sum, that is, this is the fourth question. We are dealing with the fourth question and the fifth sum in that. They have given us x plus y is equal to 3. This is what is given to us. We have to show that the maximum value of this function, that is x square y, is equal to 4. We have to show that. Okay. Now over here in the solution, we have x plus y is equal to 3. Therefore, we can write y is equal to 3 minus x. Y is equal to 3 minus x. So, in this function, we'll write like this. Let fx is equal to x square y, which is x square into 3 minus x, because y is nothing but 3 minus x. Therefore, we get 3x square minus x cube, which is our fx. Therefore, as usual, we start with finding f dash of x here. For finding maxima or minima, the first step, finding f dash of x. So, f dash of x turns out to be 6x minus 3x square. Okay, 6x minus 3x square. We also find f double dash of x, that is the second derivative, the derivative of f dash x, which comes out to be 6 minus 6x. 6 minus 6x turns out to be the second order derivative over here. Then what is the next step? We put f dash of x as 0. When this equation turns out to be 0, that is 6x minus 3x square is equal to 0. Then over here in this particular equation, we see that 3x is common to both the terms. So we write 3x outside the bracket, and inside the bracket we have 2 minus x. Isn't it? 2 minus x we have inside the bracket. Thus we get two solutions. Either 3x is equal to 0 or 2 minus x is equal to 0. So therefore, x is equal to 3, x is equal to 0 I mean. X is equal to 0 or x is equal to 2. Now let us examine this particular function. First, x is equal to 2. So from at, we say like this, at x is equal to 2, what is the value for f double dash of x? What we got just now, that is f double dash of x turned out to be 6 minus 6x. So that is the value of f double dash of x at x is equal to 2. Okay, so 6 minus 6x. Then, therefore, f double dash of 2. So f double dash of 2 comes out to be 6 minus 6 into 2, which is 6 minus 12, which is minus 6. Now minus 6 is less than 0. Therefore, we conclude that the function f has a maximum at x is equal to, what was the value? 2. X is equal to 2. Therefore, maximum value, remember how to find maximum value. We put x is equal to 2 in the question. What was the question? Our function was the question. This was the question. Okay, fx was x square y or x square 3x square minus x cube we had got. This was the question. So we put x is equal to 2 in this particular question that is there. So 3x square, see 3x square minus x cube becomes this way, f2 is equal to 3 into 2 square minus 2 cube. Okay, which becomes 3 into 4 minus 8, which is 12 minus 8, which is 4 as they had asked. Thus we conclude that the maximum value of x square y is 4. So these are the sums which come in miscellaneous exercise 4 of the lesson dealing with maxima and minima. So practice properly, students. We'll meet in the next lecture with the next concept. Stay safe and healthy.